In example 6, we need to solve each equation for the variable indicated. Then, if necessary, we'll round to the nearest thousandth. With the problem here in A, we notice that we have an exponent, that's the variable, the one that we need to solve for. Probably going to need to use logarithms in this case. What we should try to do though is look at the 6 and maybe look at the 12, see if we can change either one of these to a lower base. Turns out we can't though. 6 can't be written as a lower base, neither can 12. I mean, you could split up 12 into 4 and 3. 4 is 2 squared. But that's not going to help us out very much for this one. So right away, I think we're going to change this into a logarithmic equation. When we write a logarithmic equation, the base is going to come down below, the 12 will come over, and then we'll be solving for the exponent. Now all we have to do is just type this into the calculator and see what we get. Remembering we're going to round to the nearest thousandth. So this will be log 12, close a parenthesis, and we'll divide that by log 6. If we hit enter, we get 1.386, and then an 8 following the 6, so we'll round that 6 up to a 7. So x will be approximately 1.387. B is similar. We do have two terms up here in the exponent position, but that's still fine. We have a e here, and we can rewrite this in log form as log base e of 9 is equal to y plus 7. Remember that log base e is just the natural log, and you have a button on your calculator for that, so it's often beneficial to write it like this. And then we could subtract 7 from each side. We would have the natural log of 9 and then minus 7. The 9 is the only thing that the natural log is acting on. That's equal to y. Let's type this into our calculator, see what we get. So we've got natural log of 9 and then minus 7. We have negative 4.802 with the 7, so we'll round that 2 up to a 3. So y will be approximately negative 4.803. Should have done this one with the last one, but we'll do it here with this one. It's super easy if you're using a calculator for this, just to, a graphing calculator I should say, to substitute those values right in. So what we can do, or the value for y, so what we can do is we can just find e on your calculator. In this TI-84, it's just the second division symbol. We're going to raise that. And then I like to use parentheses. I don't think you really have to do that if you have this program where it moves it up into the exponent position, but if you don't, you definitely have to use parentheses. We're going to do second, the negative sign, which will get us our answer, so this value, substituting that in for y. Then we need to add 7. That'll all be in the exponent position. So all we're doing is we're taking our original left side here where the variable is, and we're substituting that value in. We should get 9. And we do. So this one is checked. You definitely could have done the same thing here. If you use a rounded value in your checking, you can do that. Maybe if you lost track of this. Let me show you real quick what will happen here if you do that. So we've got negative 4.803, and that's going to be plus 7. You can see that we don't get 9, but we get something very, very close to 9. So if you can use the value that's stored in your calculator, you'll oftentimes get a much better number, and it might even be the number itself. And then if you just use a rounded value, well, your answer is going to be a little rounded as well, or a little off. Just know that.